That was just crazy. Like everything shut all at once. Bleh. Thank you very much. All right. So we have carbon dioxide. Oh, and it got rid of my last writing. So we had CO2. So we have 1 carbon. And we have 2 oxygens. So those are compounds, but our next ones, those are what we call ionic compounds. Remember, these were covalent compounds, and what did they do with their electrons? They shared their electrons. Now we're going to take a look at a different kind of compound, and that's called an ionic compound. And these are made of ions, so it's positive and negative. And what it actually ends up looking like is like this. The green ones are chlorine or chloride, actually chloride ions. So the green ones are negative. And the silver ones are positive. Okay, the green ones are negative. The silver ones are positive. And they alternate. It goes positive, negative, positive, negative, positive, negative, positive, negative, all the way up and down, side to side, and front to back, 3-dimensional. Okay? And this structure here, it's a crystal, and it is called a crystal lattice. Let's write that down. Crystal. And then the second word is lattice. Lattice. Crystal lattice. Yes. Oh. Ionic compounds exist as a 3-dimensional crystal of alternating positive and negative ions. Yeah. Thank you. Now, I don't know about you, but I would probably have trouble drawing this crystal. Okay? 3 dimensions looks really complicated. But what if we took just one slice? Could we draw one slice of it? Yeah. So if I ever ask you to draw a crystal lattice, you just need to draw one slice. You're drawing like a 2D representation. So what that would look like is it would look like negative, positive, negative, positive, negative, positive, negative, positive. Or positive, negative, positive, negative, positive, negative, positive, negative. Because that way we can all have the skill to draw that. When we write the formula for these ionic compounds, Yeah. Okay. We don't write out the whole thing, like, because if I have this crystal here, if I were to count up all the chlorines and all the sodiums in that crystal, I'm just going to approximate. It's approximately 6 ions by 6 ions by 6 ions, which is a, let's see, 6 by 6 by 6. 216. Actually, that's not right, because it would be like, we would have a little group right like that, right? That's NaCl, NaCl, NaCl. There's 3 along each surface. So, is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there's 21 on that side. And then there would be 1, 2, 3, 4, 5, 6 of those sheets. So 21 times 6 is 126 NaCl's. Whew, that's a lot, yeah? Would it make sense for me to write Na 126, Cl 126? What if I had a bigger salt crystal? Right? What if I had a billion? Because like atoms are really small. You could easily have a billion atoms. Are we going to be writing, Na, a billion? Actually, just let's do 1,000 because I can't write that. Cl 1,000? No, that's crazy, right? And you can have big crystals and you can have small crystals. Are you ever actually going to know exactly how many sodiums and chlorides there are in any given crystal? No. So what we do is, instead of writing the exact number, we just write the smallest whole number ratio. Whoops, not ratio, ratio. And what's the smallest whole number ratio between the sodium and the chlorine? For every 1 sodium, there is 1,000 to 1,000 is 1 to 1. 126 to 126 is 1 to 1. Okay, so for this one, the formula is just NaCl. So there's 1 Na for every 1 Cl minus ion. So the formula is just NaCl. That way you don't have to worry. Is my crystal big? Is it small? Exactly how many do I have of each? That's different from a molecule. Is it possible for water which is H2O, could it be H20O10? Can you imagine a water molecule where you had 10 oxygens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with 20 hydrogens? That's one molecule. Do we like that? No, because water is H2O. It's never bigger than H2O. You never have a larger particle of H2O. Okay. What time are we at? We're at 20 after? Okay. Blah, 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 blah. Do, 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 do. Okay, I'm going to give you some of these for, yeah, sure, but we're doing what you call them next, so be quick. All right, we're going to learn how to use Bunsen burner today. All right, and then I'll give you a little time to, that'll take maybe 10 minutes or so, and then we'll have some time to work on the homework. So what you're going to do is, for every table has a gas, yes? When the gas is like this, when the nozzle is at right angles, that means it is off. Okay? When it is parallel, that means it is on. You want to make sure that all gas valves are off because otherwise it's going to smell terrible. Okay? And what you're going to do is you are going to go and get, for one table, you're going to go and get one Bunsen burner. And Bunsen burners are way back here. Okay? So one per table. Oh, I should have done fire safety first. That's okay. You can grab the Bunsen burner. We'll do fire safety before we do anything else. Just because there's only like one pluggy anything per table. Okay, now everyone sit down again before we get started because we need to talk safety. Because I cannot have you lighting things on fire until we are sure that it is going to be safe. Okay, and actually, Tristan and Oscar, if you guys wanted to come up to this desk, then you'll have your own little pipe gas outlet there. Okay. Now, the first thing we need to know about fire is that it will burn you, and we want to avoid being burned. So, what are some fire safety things that you maybe remember from the past or just know because you have some common sense?
Don't touch the fire.
Don't touch the fire. Very good. What else? How can you prevent yourself from catching on fire? What things might get caught on fire more easily than others? Pardon me? Pull up your sleeves. If you have dangly strings, you'll want to tuck those in. Okay, if you have long hair, I do have some hair ties. Let me go grab them. Okay, you'll want to tie back your hair. So if anyone needs a hair tie, they are there. What else? What if you do catch on fire? Despite all precautions, let's say you have caught on fire. What should you do? Should we run? If I am on fire, do I run to the fire blanket? Why not? What would that do to the flames? It would make the flames more lively, yes, because I'd be feeding it with lots of wind and oxygen. So I don't run, if I'm on fire, I do not run to the fire blanket. What do? I stop, I drop, and I roll onto the flame. Okay, because that's going to mean that the flame is not going to get any oxygen because it's being blocked by my body. Okay? Now, if you have like a jacket on, you'll take that off just when you're working with the Bunsen burner. You don't have to do it just yet, okay? But if you have a jacket on, you'll take that off. You can roll up your sleeves with other things. Now, what would you say about my space here? Does my space look good for lighting a Bunsen burner? No, why not? There's flammable stuff, okay? So, plus there's just things in the way, all right? So I don't want to have things or flammable things in the way, all right? So you can just move those things out of your way. Oh, and on the subject of the fire blanket, if your partner catches on fire, you can go get the fire blanket while they stop, drop, and roll. One other thing, and this is from personal experience, never turn your back on a flame. At my wedding, I actually caught on fire. My husband and I were up giving like a speech, right? You know, you go up and you give a speech, blah, blah, blah. It's the head table. There were candles on the head table. I had a veil.
Oh,
And we were just up there, we're talking, and all of a sudden, my very quick-witted aunt, she was up there patting my back. And I'm like, what's happening? What's happening? I hadn't even realized that I was on fire. She was nearby. Fortunately, she's very quick on her feet, very quick thinking, very quick acting, and she put me out before I knew what had even happened. It smelled really bad because burning plastic smells terrible, but all was well. Nobody, I didn't get any burns or anything like that. It was crazy, but don't turn your back on a flame because if your hair is tied back, it could still get into the flame. Also, do not leave a flame unsupervised, unattended. Okay? Anytime you leave, you're going to turn it off. Speaking of turning it off, how do you turn it off? You just turn off the gas. And in fact, I would advise not using this one at all. Okay, not using this little doodad. I'll explain it in a moment. But I would just, if you want to make the flame higher, turn the gas on to full. If you want to make the flame lower, turn the gas down. Does that make sense? Okay. Now, let's take a look at our Bunsen burner. And what I would like you to do is I would like you to take this little bit here and screw it out all the way out. All the way out. Okay? And I want you to look on here. Can you see a black rubber O-ring? Yes. That black rubber O-ring is what prevents the gas from shooting out the side. So if you screw it in and the black O-ring isn't far enough in, guess what can happen? Flame can shoot out the side. So we don't want that. On the other hand, what's going to happen if you screw this in all the way? Do you know what happens? It completely blocks the gas. Okay? So this little pointy bit on the end, get this out again. The little pointy bit on the end completely blocks off the gas flow. So you don't want it to be too far out, but you also don't want it to be too far in. So my suggestion is you want to screw it in until you can only see the tiniest sliver of the black O-ring. Okay? Just the tiniest sliver of the black O-ring. All right. And now, one more thing before we get too excited. There's little windows at the bottom. See if you can open and close them. Occasionally there's one where they don't work very well. So make sure that you can open and close them. Do you know what the windows are for? Don't know what the windows are for? Yes. To let oxygen in, okay? If you let oxygen in, the flame will burn hotter, which is generally what we want when we're working with it, okay? Now, has anyone ever tried to light a fire outdoors, maybe when you're camping or something? Anyone? How well does it work if the wind is blowing? Not very well. It's very difficult because the wind keeps blowing out the flame. So if you have these windows open, there's a chance that the oxygen coming in will blow out the flame before it gets a chance to start properly. So it's best to light your Bunsen burner with the windows closed, and then when you want it to get hotter, what do? Open the windows. All right? And I will just give you a quick demonstration, and then I will let you get your own. Oh, I got to turn on the gas too. Everyone, gas is off, otherwise it'll smell bad. Okay. Okay, I'm going to show you how not to do this. Okay, now I'm holding this up so you can see it. Obviously, you wouldn't hold it up anyway. But this is how many students try to light the Bunsen burner. Are you seeing any sparks? No, right? You actually need, there's a flint here. Okay, there's a flint. And if you happen to get this one, you might actually notice that the flint is almost completely gone. Okay, it's lying, it's flush with the steel part around it. Okay, so you might ask me, could I please get a new striker, and I will then replace the flint. Okay, but let's see if even with this one that has hardly any flint left, there's a rough piece of steel, and it's the friction between those two that causes the spark. Did I get a spark?
Yeah.
So I'm getting a spark even with very little flint left. And the reason is that I am pushing forward on the steel part and I'm pulling backwards on the flint part. And if I do that, I can actually get enough pressure that it will spark. If you want a lesson on how to do that specifically, call me over because it's something that's really hard to learn from back there. Basically, what you do is you take your right hand and you face the palm towards you, like you were going to bang your head with your palm, okay? Right hand towards you. You put this into your right hand and you hold it down at the bottom. Down at the bottom. With your left hand, and this is the tricky part, you make an L. You push forward with your fingers, but you pull backward. You use your thumb like a hook, and you pull backward with your thumb. Okay? I know, it sounds hard, but basically you're pushing with your fingers and pulling with your thumb, and then you get a nice spark. If you are not successful in getting a spark, call me over and I can show you how to do that. Every single person should try lighting the Bunsen burner. If you guys are a group of 4, you could actually get yourselves a second Bunsen burner so you could each have a chance without having to wait so much. Okay, and what we're going to do now is I'm going to just show you how easy it should be to light. I'm going to turn down the lights so you can see. Okay, gas on, Bunsen burner lit. That's it. Did you blink? Did you miss it?
Yeah.
Okay, I'm going to do it again. I'm going to turn it off. Davey, look up here. Okay. Okay, gas on.
Oh.
And you'll notice I'm holding this like pretty much facing directly down and about this far away from the actual thing. So it's not facing sideways, it's facing downwards, and it's quite close. And sometimes it kind of goes boom and you feel a little bit of warmth, but I've never had anyone get burned by it. Now, I want to open the windows. The bottom part, it's actually cool enough all the way up to midway through. Ooh, look at that, exciting. We've got some other chemicals in there. Red, it looks like we've got some strontium burning off. That's a hotter flame. Do you see how there's a little flame in the middle and a bigger flame on the outside? That's a hotter flame. Then you'll turn it off, and you'll turn it off. Now, what if I turn on the gas, and I'm like, oh no, it's not lighting. This is very typical. Don't worry. Don't worry if it happens to you. It happens all the time. It's not lighting. Oh no. But what's happening is you're getting a big cloud of gas building up. So if that happens for too long, turn this off and do the gas away dance. Gas away, gas away. Everyone show me the gas away dance. Gas away, gas away, Gas away. Gas away. All right, and then you can try again. You can turn on the gas again and try it again. All right, so I am going to put your strikers here. Okay, I'm going to turn the lights up just a little bit so you can see better. Hair ties right here. Anyone else need a hair tie? Don't forget jackets off. Don't forget tuck in your strings. Yep, you can go ahead. And I'm just up here so I can see you all. Call me over if you're having trouble. So you can just push those papers to the right-hand side there. There you go. Gas away. Gas away. That works too. Nice. We got a lid over here. Nice. Make sure everybody gets a chance to try and light it. If you're having trouble, call me over. Okay? Well, your gas is off there. You would need to turn the gas on. No, that's off. That's off. Yes. Turn the gas on, then you light it. Yeah. This one has a beautiful flame.
Yeah.
Did it work?
Oh,
Hold on. Let's just make sure the gas is on. So what we're gonna do, okay? Come around to all right. All right. So what you're gonna do is you're gonna put this in your right palm.
I was like glitter.
Oh. Now you're gonna take your left hand and you're gonna push these fingers and you're gonna pull backward into your thumb.
I made it red, yeah.
Then you're gonna do I get a spark? Yeah. So now you're going to do this like this. Nice. Oh,
Miss Spence.
yay!
That makes sense.
You know, doing science.
Oh yeah, and laziness brings.
Somebody threw that's this that's where
I think it's that other hand. So, take it out. I'm just gonna move my fingers. All right, here we go. Right.
Oh, yeah. So their hands not using your
When everyone has lit their Bunsen burner, when everyone's had a chance to light it, then you are going to cool off. You are going to take off the gas, and then you're going to put it away. All right?
I didn't. Oh, the gas cut. We could like. But what about just like all the gas?
Okay. Bunsen burners away, strikers away. Your homework is pages 9 and 10. 9 and 10. Okay? Thank you very much. Okay, stop. It wears out the flint.
I like really it's totally gas. I wonder why.
I wonder why.
What's your homework?
Page 9 and 10.
It's 9 and 10.
I don't Oh, it's not that. Is bro. Yeah, how much was actually?
Thank you.
There's like the test club, Actually, what's here? Channel is just.
Spence.
Yes.
Two are elements, right?
Yes, they are.
All right.
Yep.
When are we getting our sports?
Oh, your Parish splits?
Yeah.
Hopefully, like maybe tomorrow. Fingers crossed.
All right.
That's okay. What?
Yeah. If you come in for blood, that's great. If not, we can do it in class. Okay. Yeah.
How much do unit tests add to your marks?
Unit tests are worth 80% of your grade. So pretty much that's what it is. Quizzes are just kind of there to, like, let you learn things. And I would give you more marks on the lab, but I don't have a tendency to remember the wrong things. So, I don't, yeah.
Okay.
Yeah.
All right.
See you tomorrow. Okay. Yes.
Yeah.
It's kind of obvious in that, yeah. It's like, oh. Happy ground. So we'll start with these ones, okay? And I'll come over and just look beside you, okay? Just need to get one. Anytime it's only multiplying or dividing, all multiplying.
Just to remind you that there is a grade 8 boys volleyball meeting happening now in room 113. Grade 8 boys volleyball meeting happening now in room 113.
Okay, good. Okay. thousands of people were like, I'm gonna come in and do my corrections. How many have I seen? One this morning and one now.
How did you forget? To be honest.
How can you get like 100% and just forget that you should come in and how? How? We all have phones to set alarms on. Okay. All right. That looks good. Yep. Okay. Excellent.